Okay, my friends, we are back at it, and today we are going to talk about anemia and iron. So I know it's kind of a loaded question, but talk to us. Let us know about this anemia.
Okay, so one of the important part is through all my research and many years of trying to understand the concept of human health and metabolism was all life we all heard, me even as a professional, medical professional, anemia is iron deficiency. Anemia is iron deficiency. Actually, it's not. If you look at any type of terminology and description of definition of anemia, it actually is not iron deficiency. It is a deficiency of utilization of iron, regulation of iron, absorption, or distribution. Whichever term you choose, it's correct. I choose to use term dysregulation. The reason is, as we're going to go a little bit further, it happens in so many different aspects. Okay, when people think about anemia, they always think about one thing: level of iron. There is so many different markers, and new scientific approach right now leads to those markers to start to understand anemia as actually a lot more complex metabolic problem with iron versus just deficiency. And also we've seen that the deficiency, they don't create any improvement with anemia. And a lot of times they create problems because people, when they don't absorb or regulate iron, by taking iron, they create iron overload. And iron overload becomes a really serious problem for every human being. So going back to anemia, it is distribution and dysregulation. Where iron is supposed to be delivered and how it's supposed to be delivered. Now, glucoferrin plays the big role. In order to regulate iron, human body has to have a 708 amino acids called sulfur bonded. Sulfur is basically a glue of amino acids, simplifying, of course, to create a full sequence of protein. Those proteins have an ability and are specially designed in our body, in our mother body, to bind iron. That's why it's referred iron binding glycoprotein. So when you start to have this protein, you start to distribute iron to the bone marrow and to liver, to the storage places called ferritin. These are the amino acid cells which stores iron. Okay. Now, anemia can actually be established in certain body parts, but this doesn't mean it's an anemia of whole body. It's basically localized anemia, which is caused by somewhere in the body, multiple iron overload areas. And one of the first one is always a liver. So liver iron overload will actually cause iron deficiency in certain organs, but in general in the body, in distribution regulation, it is iron overload and iron accumulation would happen versus iron deficiency. Secondarily, basically today in the world, to become iron deficient, it's basically impossible. The reason is iron is in everything, including it's added as a food fortification. So it's basically in every single grain, every single food, it's iron fortified. So we have iron from the breakfast to every meal full of iron. We have this also in vegetables, iron. We have in meats, iron. Okay, so we're getting loaded with iron every single day. So technically, you cannot be iron deficient. You just start to accumulate iron because the body loses ability to properly distribute and delegate iron with red blood cells hemoglobin to be formed to the bone marrow and hemoglobin to deliver to rest of the body. And that's actually the name of anemia. It's an iron overload and dysregulation of iron distribution, not deficiency.
This makes me think about women, obviously, or a lot of people that I know that would like get iron infusions. So can you talk a
Yes,
little bit about that? Like I'm like so I'm trying to like think of a simple way to just say, so I'm not actually low in iron. The test is saying that it's just distributed, it's in other organs instead. It's just hanging out
yes,
somewhere else, right? And I need to find
yep,
a way to properly utilize that iron.
yes, correct.
So then I have to sit, and then I see women are sitting in these chairs and getting multiple infusions over and over. So what's really happening to the body when they do that?
Okay, so the first thing is the understanding of iron deficiency was done 30, 40, 50, 60 years ago. And now many scientists, professionals come to the conclusion that we have to look on iron differently. So iron is basically checked on iron level or hemoglobin, which is completely incorrect. Okay, so we need to check different types of markers in the body. When hemoglobin is low and iron is low, okay, you're going to have showing in certain deficiency, but yet when you check levels like, and I give you the markers, for instance, ferritin, which is the storage cell for iron, transferrin, which is the transport protein for iron, total iron binding capacity, which is the measurement unit, how we form and how well we form red blood cells, okay? And then we check iron levels and concentration of percentage of iron. Then a skillful professional, we can establish actually where the dysregulation happened. So by looking on all those markers, you can see how actually high deficiency is in the iron distribution, not actually being in the body. Second thing, it's very important to remember that iron needs to be delivered to the bone marrow and to liver. Bone marrow is the one which produces 80% of bone marrow. It's a red bone marrow and produces red blood cells. That's where the red blood cells has to have iron to be delivered. The first thing when iron is delivered, there has to be present iron binding protein. That protein does not exist anywhere, just in mammals. Mother's milks the most abundantly, and then also in meats of all mammalian species. Okay? Without that protein, we start to have a dysfunction of the binding process, which is the creating of red blood cells. Red blood cells also require, besides these amino acids, iron binding amino acids, okay? It requires also iron, which is two types of iron. There's a heme iron and non-heme iron. Heme iron comes only from mammalian animal source. It is not available in vegetables at all, okay? There is in some fish, but certain type of fish. So when we don't have a heme iron, heme means hemoglobin, which means it's very easy to bind that iron to create hemoglobin and red blood cells and then molecules of hemoglobin. The second iron from vegetable source and grain source or fortified foods, it's called non-heme iron, which means there is no heme part. Heme is a particle element in human body which naturally binds with iron. Heme iron binds with what we call this F plus 2, ferrous iron. And ferrous iron becomes heme iron, and it's very easy to create red blood cells in hemoglobin. That iron is F plus 2 and it's called ferrous because this is the natural way that our body can actually bind with oxygen, which comes also as a O plus 2. So they have an affinity to bind together to create perfect delivery of oxygen and then glycogen in the body. The non-heme iron does not have what they call pyloric ring, which it means does not come an F2 form of iron. It will create non-heme, which is F plus 3. Our body cannot utilize F plus 3 because there's a ferric iron. That ferric iron needs to be broken down to F2. And that's where the glycoprotein, like glucoferrin, comes important, because the second function of mother's milk, besides binding, is sequestering part. Sequestering part is based on dividing the F3 to F2 and F1 to utilize it. So that it has to be broken down. In the non-presence of that amino acid, sulfur bonded binding protein, the process of binding iron from non-heme, it's extremely difficult, and it's have a very difficult time to bind with oxygen. And that's what people who have very low protein, proper, animal source protein or dairy product, which are, from mother's milk, of course, they have a severe problem to bind and create red blood cells and hemoglobin, and that's where they become very, very soon what they call anemic, and they think they iron deficient. They're not, because the F3 iron, if it's not broken down, or if it's broken down, the molecule left over, which is the ion of iron, becomes what we call free floating iron. The free floating iron, it goes in our body and it start to get accumulate first in our liver and the rest of the organs and the rest of the systems in the body, creating severe iron overload, which is actually anemia, but the iron is overloading the system. The second part is, after iron overload, we go into the stage called hemochromatosis. Hemochromatosis is the name coming from heme, blood, chroma, Greek words from color. Our blood becomes so thick and brownish from iron substance floating in the bloodstream. So then is recognized as a hemochromatosis, bronze diabetes type 2, because of the brown color of the blood. The third stage of it, it's called ferroptosis. Ferroptosis is severe accumulation of the free-floating iron in the body, which causes buildup of oxidative stress damage and iron molecules building up, basically corrosion of our cellular level, and start to suffocate it and block even further delivery of iron and hemoglobin with oxygen and glycogen to the cells and the very further body parts like brain or organs, creating very, very difficult sustainable environment for the cells to be alive and to replicate. Well, oxidative stress is the main reason of every metabolic abnormality and causes to multiple cascade of the health problems. Now, ferroptosis definition was done for the first time in 2012 in United States as official medical terminology as a accelerated cellular death due to iron overload accumulation on the cellular level.
Well, we're going to dive into the metabolic disorders and stuff on our next episode, but I'm so grateful that you were able to break that down, because I had some aha moments in there myself, especially being told that I have low iron my entire life. So I appreciate you being here. Thanks again. And if you guys have any questions, just make sure you put it in the chat.